Hi guys, welcome back to AGT STEM. Today we're going to be watching a video about nitrogen. So, without further ado, let's hop to it.
Nitrogen is an extraordinarily important element. We could make hundreds of YouTube videos about nitrogen and still not tell you everything. So Neil and I and Brady have been in the lab. We've done what we think are some quite nice experiments just to give you a flavour of some of the things about nitrogen. So you'll see me trying to smash a banana, you'll see brown gases being generated, sodium azide going off in quite a spectacular manner, and one or two other things. So it's really fun.
I like his tie, it's periodic table tie.
Fun, but there is some quite solid chemistry behind it.
Are they filling it with nitrogen?
Liquid nitrogen, which boils at minus 196 degrees centigrade, is used as a coolant all over the world in laboratories and industrially. When nitrogen comes out of the container, it's obviously cold, and you can see in the thermal imaging how the low temperature cools everything around it. It also freezes the water vapor in the atmosphere. So you get quite nice clouds of what look like steam, but is actually tiny particles of ice.
That's pretty cool how that happens. Like, they could probably use it to freeze like a whole bunch of things really efficiently, and it'd probably stay cold for a while. But I guess like it's probably too cold for anyone to touch, so. Now they're gonna freeze a rubber glove. Well, that's something.
I used to use it. My shoes cracked through freezing in liquid nitrogen. I never tried freezing a banana.
Why do you want to freeze a banana? Kind of a random thing.
Brady wanted to see the professor trying to smash a banana.
Bang.
When you cool things in liquid nitrogen, fruit, for example, that contains water, the water freezes, so the banana goes absolutely rigid. And then if you hit it with a hammer or something else, the ice shatters, and it can make quite a spectacular mess.
That's pretty cool.
The sort that Neil hates. Chemists use liquid nitrogen, first of all, because it's safe.
I wonder if you could like freeze things that are harder, like if you took wood, could you freeze it with liquid nitrogen and then it would just shatter like that? Or does it only work with things that have water?
Liquid oxygen would cause, or potentially could cause, fires, explosions. You've seen liquid oxygen and cotton wool going whoosh! Also easy to obtain. It's a major component of air. It's quite cheap to make. Also, it has a convenient temperature of 77 degrees Kelvin, minus 196 degrees centigrade, which is a useful temperature which freezes most things, most gases, most things that you use in the lab. Sodium azide is a salt of sodium, Na+, and the azide ion, N3-. Azide comes from the French name for nitrogen, azote. N3- is potentially a very unstable anion. If you heat it, it can turn to nitrogen gas. N2 has a very strong bond between the two nitrogen atoms, so it releases a lot of energy. So we tried heating sodium azide. The reaction is quite simple. It goes to nitrogen gas and sodium vapor. The sodium immediately reacts with oxygen and water vapor in the atmosphere. So you get a orange-coloured flame from the reaction of sodium.
Oh, yeah. Kaboom. It's kind of like firecrackers. Maybe that's how they make. Like sparklers, because it looks very similar.
Sodium azide is one of the components that's used in airbags in cars.
Huh.
The car, if it's crashing, heats a charge of sodium azide, which is also mixed with some other chemicals. It releases nitrogen gas very quickly and blows up the airbag.
One safety device that looks likely to be compulsory soon is the controversial airbag. This drawing shows how it works. In a crash, a small detonator releases compressed nitrogen from a tube, and this inflates the bags concealed in the dash and the steering column.
But
Like
I've
a
never
giant
seen
bubble.
it heated up. Neither Neil, actually. It's really quite beautiful when you heat it up. Other azides, particularly of heavy metals like lead, silver, mercury, are sometimes used in detonators to set off explosives, because if you bang them, they decompose very rapidly. Although nitrogen is very unreactive, it can be persuaded to react with oxygen, and it forms a whole series of different oxides, compounds that contain nitrogen and oxygen, and their properties are very different. The most stable one is called nitrous oxide, sometimes called laughing gas, N2O. N2O has the property that it dissolves very easily in fat.
So we use N2O to like whenever you go to the dentist, or I don't know if they use it for other things. I've only ever had to use it at the dentist.
Your brain and mine is largely fat, and so N2O dissolves well in the brain and is a very good anesthetic. It's used in childbirth, but because it dissolves well in fat, it's also used as a propellant.
So yeah, you do use it for other things like childbirth.
For instant cream.
Whipped cream.
Brady and I and Neil had quite a lot of fun squirting out instant cream just to show you the nitrous oxide in it. The cream is pressurized with N2O, probably to not a very high pressure, an atmosphere, a few atmospheres. When you release it, the dissolved N2O bubbles out, so the liquid cream suddenly goes into a foam ready to go on your cake.
Is it still in some of the cream when I eat the cream?
There's probably some N2O left in the cream, but if you wanted to anesthetize yourself by eating cream, you would vomit long before you had enough to have any serious effect. The other two oxides of nitrogen are NO, nitric oxide, and NO2, nitrogen dioxide. They're both quite unusual because nitrogen has 7 electrons and oxygen has 6. So both compounds have unpaired electrons, which gives them slightly unusual properties. It's quite easy to make NO2. The standard way is just to heat up lead nitrate. Lead nitrate is lead 2 plus NO3 minus. And when you heat it up, you form lead oxide, which is a sort of slightly yellowy orange color, and you make NO2, which is a brown gas. And when we heated it up, we got really quite a sort of substantial plume of NO2.
That's kind of a scary liquid, or gas, because it's like
itself
reddish.
Can, because it has an unpaired electron, can dimerize. 2 of them form N2O4, and which is a liquid at room temperature, and that we have shown on one of our other videos can be used as an oxidizer for rockets. For example, the lunar module taking off from the moon used N2O4 as the propellant.
Now it's very volatile. It boils at 21 degrees C, so we have to keep it cold, and we put it into the reaction chamber.
There's another way of making NO2, which is the reaction of concentrated nitric acid. It's important that it's concentrated with metallic copper. And we did this in glassware so that we could collect the gas and see what happened. So we had a vessel with the acid coming in at the top, the reaction taking place, and a tube at the side going into water so we could collect the gas. You can see that when the acid went in, there were clouds of brown gas generated, the NO2 as before, and it went down the tube and there was bubbling as it came out. Now, we had some quite strange effects, which we hadn't anticipated. It's one of the exciting things about doing chemistry demonstrations, that sometimes, although you understand what's going on, you see effects that surprise you. When Neil added a bit more acid, the NO2 started dissolving in the acid. It was already saturated in the acid that was there, and there was a momentary pressure drop which was enough to suck back the water into the vessel. And once the water was sucked back, the NO2 went on dissolving and dissolving, so the whole lot filled up. And the solution went nicely blue with the colour of copper nitrate. The interesting thing about this reaction is that if you use dilute or more dilute nitric acid, instead of generating NO2, you generate NO, nitric oxide, which is not very soluble in water. So it bubbles out and you can collect it in an inverted test tube. But NO reacts very easily with the oxygen in the air to make NO2. So when you take the test tube of NO out of the water, air can get in, the oxygen in the air reacts with the NO and makes the brown NO2 gas. Now, the relevance of all these nitrogen oxides is that in the high temperatures that you get, particularly in diesel engines, the nitrogen in the air and the oxygen in the air can combine to make small amounts of nitric oxide and NO2, nitrogen dioxide, a mixture which is conveniently called NOx, because X is somewhere between 1 and 2. These nitrogen oxides in the air are very bad for the air quality. When people breathe them in, it can cause all sorts of breathing problems. And NO2 dissolves in water to make nitric acid, so you can get that nitric acid formed. And so NO2 and NO are important environmental pollutants.
Why does this only happen in diesel engines and not car engines?
Diesel engines operate at a higher temperature than petrol engines, which is why they are more fuel efficient. So in terms of carbon dioxide, the emissions for diesel engines are lower than for petrol engines. You can get more energy out, but in terms of nitrogen oxides, it's not so good.
Well, thanks for watching, and we'll see you next time. Stay smart. Bye!